So in this lesson, we're going to start getting into your gas pressure regulators. Well, for the purpose of your gas regulator is to, just as the word states, it's got to regulate the gas. It's got to monitor what is coming in to the home or to the place of business. Okay, gas is pressurized at different pressures for delivery. Okay, so I get propane. It may be stored at about 125 psi inside their tanks. Your gas mains for all of your natural gas lines, they're coming maybe in from the street at around 10 psi. So the gas regulator is there to reduce the pressure to the required levels for use. The pressure requirements for individual pieces of equipment are designed and specified by the manufacturer. And natural gas is delivered at approximately 5 psig and can be as high as maybe as 15 psig. So whatever the pressure is that's coming in from the street, that regulator is going to take that pressure and reduce it down to a safe level so that it can be used inside the home or, again, at this place of business. Your typical burner manifold pressure that's operating your burners is going to be at 3.5 inches of water column. The pressure may be reduced twice, once at the meter, and again once at the appliance to prevent any sort of fluctuations. So when you're looking at a natural gas line or even a propane line, you may have one or more regulators in line with that particular appliance. You'll have a regulator outside that's going to take the street pressure and reduce it down so that it can be used inside the home. And then you may have another regulator which will reduce that pressure down to what can be used at the appliances. It all depends on building construction, so on and so forth. But that's pretty much the ultimate reason why we have gas regulators. We have to be able to control what we're dealing with. The components of a gas regulator is going to be pretty much a diaphragm, a spring. We'll have an adjustment screw in there, a valve, and a seat. The diaphragm is what separates the spring and the adjustment screw from the outlet gas in low pressure. And when the gas leaves the regulator, it meets resistance from the burner orifices, and the resistance causes pressure to build up under the diaphragm. As pressure reaches the set point, the diaphragm lifts the valve and closing it. And when the gas valve is open, the regulator will not close completely, metering the gas at a set pressure. When the gas valve closes, the regulator will close since there is no more flow. When adjusting a gas regulator, the adjustments on it are under the vent cap. So you're going to turn the screw clockwise, and when we turn it clockwise, we are going to increase our pressure. And when we turn the screw counterclockwise, we decrease the pressure. Your LP tanks use different types of regulators than natural gas. The pressure at the tank can be over 125 psig when the tank is in the sun, and the pressure must be reduced to 11 inches of water column for use at the equipment before entering the building. So what you need to make sure that you are understanding when it comes to your gas pressures, whether you're dealing with natural gas or propane, is that natural gas burners will operate at 3.5 inches of water column, and your propane burners will operate at 11 inches of water column. The reason why they operate at different pressures is because of the gas properties. Remember, natural gas is a very light gas. We do not need that much pressure to make it flow. Propane is a much heavier gas. We need a higher pressure to make it flow. LP regulation, the first regulator is going to lower the pressure to about 5 psig at the tank outlet. The second will lower that pressure to about 11 inches of water column before it enters the building. This provides a constant pressure as tank pressure changes with temperature. When it comes to venting your regulators, some regulators vent through the vent cap over the adjustment screw. Some regulators are sometimes installed near the equipment and vent to a standing pilot. So if there's any gas leak, it passes through the diaphragm and the pilot will burn off this gas. If the regulator is mounted away from the furnace but still inside, you need to vent it outside. All types of vented regulators must be kept clear. Nothing can be blocking the vents. If the vent is blocked, the pressure will build under the diaphragm, not allowing it to close the regulator. And if the vent is blocked by a bee's nest or a block of ice, snow, the regulator will not work correctly. You can overpressurize your lines, you could damage gas valves, you can overfire furnaces, so on and so forth. The regulator will then not operate and maintain any sort of pressures. If the regulator is not operating correctly, you need to check the vent first to make sure it is not blocked. Regulators mounted outdoors must be mounted in a way or covered so that water cannot get into the vent openings and freeze.